Right, first hour, Algebra 2. Today's Monday, so happy Monday. We'll get this week going today. This week here's what we'll do. We'll have some instructions, short videos for Monday, Tuesday, and Wednesday. Thursday will be some kind of a review of the week, and then Friday, I'll give you Friday as a catch-up day. Again, I'll still give you till Saturday to get everything done. Okay, so you got some time this week. We'll build in a catch-up day on Friday for you. No new lessons on Friday. All right. So we've been looking at these sequences, either arithmetic, where we added or subtracted a number all the way across, or geometric, where we multiplied by a number all the way across. Sometimes that was a fraction, so things got smaller. But today we're going to look at something called a series, okay, also known as summation or sigma notation. All right, now simply what that means is the Greek letter that looks like a capital E that you see down there, that's called sigma. All right, so sometimes this is called sigma notation, sometimes it's called summation notation. And when you see summation, you see the word sum. That's going to be a clue as to what we'll do. But here's what it looks like, okay? This is what summation or sigma notation looks like. You got that capital E, you're going to have some kind of a number here on the bottom, some kind of a number here on the top, and then you're going to have a rule, all right? Now, what everything is this A down here, it's actually called a lower bound. If you looked up in a textbook, they would say lower bound. We're going to simply call it our starting number. The B up top is called your upper bound. We're going to simply call it our stopping number. And then the rule that we see here will be some kind of an expression that will have a variable in it, something we're familiar with seeing. Like if you look down here at number 1, you see an I plus 2. That's what it will look like for a rule, all right? Now the way this works, remember summation. What does the word sum mean? That means you add things up, all right? So we've been dealing with these sequences, let's say 5, 10, 15, 20, 25, blah, blah, blah. So we see that we're adding 5 as we go across. That's what we did, a couple weeks ago. Now what this sigma notation makes you do is it makes you take all of those numbers and add them up. Simply that's what it means. So a summation, what do you get when you add everything together? All right, now what numbers do we add together? Because this list up here will go on forever. We just keep on hitting plus whatever, plus whatever, plus whatever in our calculator, and we'll never stop. Well, that's why there's these two boundaries. So let's look at number 1. This says, the way you read this is where you would say the sum, that's what that little fancy E makes you say, the sum from I equals 1 to 6 of 1 plus 2, or I plus 2. You just look at this as, this means we start at 1 and we're going to stop at 6. That doesn't mean 1 plus 2 plus 3 plus 4 plus 5 plus 6. What that means is you plug in a 1. Now when I plug a 1 into here and I get 1 plus 2, I get an answer of 3. Then I plug in a 2. 2 plus 2 is 4. Plug in a 3. 3 plus 2 is 5. Plug in a 4. 4 plus 2 is 6. Plug in a 5. 5 plus 2 is 7. Plug in a 6. 6 plus 2 is 8. So we stop at 6 after we started at 1. And what answers did we get? We got 3, 4, 5, 6, 7, and 8. We can see how we're adding 1 as we go across there. Now all we do is add those up. So just punch them in your calculator, do them in your head, however you want to do it. Add them up going across. One trick for this is you could say 3 plus 7 is 10. 4 plus 6 is 10. That's 20. Plus 5 is 25. Plus 8 is 33. We get 33 for our sum. That's what sigma notation makes you do. It's very honestly, it's a fancy way to make you add up all these numbers, but it tells you how to generate the numbers that you're adding up. Okay, that's what the start and stop numbers are for. All right, let's do one more. Okay. Now, the rule we have out here, it can be any rule, doesn't matter. The last one was I plus 2, this one's K cubed. Your variable you use here can be any variable. Just whatever variable is there in that lower bound will match what variable is in the equation. That's the only thing that has happened. They could both be x's, They could both be N's, I's. I's are used a lot, N's are used a lot, K's are used. But it doesn't matter as long as they're the same. Now what is this telling me to do? I start at 1, or I start by plugging in 1, and I'm going to stop when I plug in 5. So I'm going to plug in 1, 2, 3, 4, 5, and I'll be done. But what happens when I plug in 1? I get 1 cubed. We'll cube them all here. So when we plug them in, let me fix that one. We're cubing whatever we plug in. So 4, we would get 4 cubed. 5 would get 5 cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. I add all those numbers up. I stop right there because that's the numbers I was supposed to plug in, 1, 2, 3, 4, and 5. Add them all up, and you're done. And I got 164. Okay? So that's all today is, just an understanding of what this notation is and what it makes you do. So we really got to pay attention to the number that we start plugging in and the number we stop at. And we plug them into our rule here. Whatever answers we get, 1, 8, 27, 64, 125, we add everything together and get one single answer. That's all there is to today. Okay? All right, so until see you tomorrow, you got a short homework on this. It'll be posted. All right, have a good day.